what is going to be the solution? The solution is that we accept that we're going to have collision. So instead of trying to avoid it, we're just going to handle it, right? That's going to be the idea. So the separate chaining is going to be used to handling the collision. So basically, it's kind of like become like a hash table. Sorry, I said hash table, linked list, right? So in our hash table, we're going to have linked lists. Anytime we see collision, instead of now start doing probing and finding another empty location, we're going to say, okay, we're going to have collision, so let's just put them in the same location together, using a linked list. So that is still going to keep us in a good shape if our hash function is really distributed well, and there are just some objects or there's some keys that are going to have the same index. Then they happen to have the same index, or they have the same key, basically, as far as calculation based, or they have the same hash. Then we're only going to have like some of them doing this, and that means it's still going to be in a constant kind of shape, right? So for example, here maybe adding 26, the key of the 26, the hash function of it is index 4, and that is similar to the key 4. So both of them are now in the same index. It's just that we're going to have a kind of like a linked list here. So when I'm looking for a 26, I know I'm using the separate chaining basically idea to handle the collision. So it's going to searching for it inside this. So it can be kind of like a linearly search for it. We know our hash function is really bad and performing bad whenever we see that this linked list here is everything else in this is almost empty, and then suddenly there is one index that all the elements are going to go there. That means our hash function is not really calculating the the index that's in a distributed way, or we have to change it, because again, that's back to the kind of data that we have, that we're trying to store them in our in the hash table or hash map. So whenever we find those, we need to kind of start changing our hash function. So there is no one single solution for hash functions. You have to see what is the kind of type of data that you have, and then what kind of a hash function is going to give you the best distribution. If the hash function not working well, then you can assume that, and you can kind of see that, then it can be like one index has all the elements in it. So if you have an element, then searching for that, it can take you order of n in that index. So it's going to be no longer hashing everything in the like a long linked list in one index. So it's going to be more like a linked list. So it's going to perform as order of n. It's no longer going to perform as order of 1 or a constant base. So basically, this is the best solution, but at the same time, you also have to make sure that your hash function is going to work with the data that you have. So you always have to kind of do some try and error, and you finally find your best hash function. Another thing I forgot about double hashing is that double hashing, sometimes the second hash give us, for example, 0. So if that happens, we're going to stay in the loop, right? So we're always going to kind of get back to the same exact location on the map, on the hash map or the array that we already check, and we already know that it's not going to be empty. So that's another problem that we may have with the double hashing. So that hashing has a lot of application. Most of the authentications happening using the hash function, like for example, passwords going to be encrypted, decrypted, and those kind of things. They're kind of using the hash to storing the caching to store using when you're trying to do caching data inside your system or somewhere, you're going to use hash your map basically to do that. Search is going to be one of other useful. Obviously, it's going to be very fast, right? So that's why we're going to use it for searching purposes. So it's very useful. So here you have a homework about it. Homework number 7, I believe, have a problem that asks you to use all these hash functionality, all these hashing, so linear hashing, quadratic hashing, double hashing, and then handling collision using the separate chain hashing to solve the problem. And on one of those, if you start doing it, you see that one of those, I believe on this one, and double hashing, you can see that you keep staying inside the loop. So I wanted you to see that problem. So don't get frustrated over the, I keep getting the same and the same locations that already are full, and that's exactly what I want you to see, the problem that we have with those types of hashing. And then we can solve the problem using the separate chaining, and hopefully that hash function that we use can distribute everything in a very good evenly way, so we can put things in their order. Another important thing I want to talk about is the fact that, and you can see that inside some of these animations on the uh, uh, book website, the size, like array lists, if you remember, if we have array lists and we're getting close to become full, we double size of the array. So here is exactly going to be the same concept. So we're going to get to a threshold, and we know after that threshold, we're going to have a lot of collisions. Basically, we're getting close to be full, and so that means we're going to see a lot of collisions. So whenever we get into that threshold, we start doubling size of the array. And when we double size of the array, we have to rehash because all the indexes going to change. So that's something you also kind of have to consider, that whenever you keep adding elements and you don't know already from the beginning how much element you might have, then this overhead of the fact that you have to double size of the array is going to happen. So that's why you always can see, even also maybe on the slides and maybe also on the video, I'll try to make it a little bit larger so you can see that. On the top, as you can see, we're talking about size of the table, number of elements, and we have a load factor and load factor threshold. So the threshold, like here, 75%, is the threshold that's telling us in the separate chaining, whenever I get to almost 75% full, then I'm probably going to have a lot of collision from now on. So we need to double the size of the array. So it's going to double size of the array. It's going to basically do rehashing. So load factor is the one that's going to be calculated, and whenever the load factor is getting close to load factor threshold, it's going to start double sizing the array, and then it's start the rehashing again. If I go to the previous slide, like here, for example, this is for the linear probing, right? So the threshold on this one is a little lower, right? So it's not 75, it's only 50%. And that's because in the linear probing, we're going to have more collision, and then we also have clustering problem because we're not handling the collision, right? We're just trying to avoid it, and then we're creating this clustering issue. So our threshold is even lower. So even whenever we get to the 50% full, we have to start rehashing and doubling size of the array and so on and so forth. So I really encourage you to kind of go inside this website, do some sort of a animation for yourself, and trying to see like how this hashing works and how you're going to be able to double size of the hash, stuff like, or not, automatically this threshold is going to make that happen, and then rehashing is happening. So this, and plus this exercise, and plus the homework that I gave you, is going to give you some kind of practice and some kind of understanding, some sort of understanding about the hashing. In our course, we don't expect you to be able to implement anything using hash and hash functions. We already talked about the fact that there's a hash code method inside object, basically. So it's suggested to be always overridden for every single classes that you implement. But we didn't really talk about it, and here we're not talking about it. You know, at the end of this slide, you can find some information about those in case you're interested to go ahead and look at it, but it's not part of this class really. So that's why I also didn't talk about it. And I'm not going to go to the coding part of it. So for this and for the graphs, we don't really want you to do any coding. We just want you to have some idea what hashing means, what kind of hashing we have, what we mean by hashing with separate chain, those kind of ideas. So we kind of prepare you to have some basic understanding of it for later on. But we're not really expect you to be able to implement a hash function or work, use, write a code for it. Okay, so that's all. Please do the homework 7 and review this slide and this video again, and let me know if you have any questions, suggestion, or comment, and post your question, suggestion, comments in the e-learning. Also, make sure you review all the deadlines for everything so you're not missing anything right